on a weekly basis, but YouTube doesn't. So if you want to watch on YouTube, it's just about to start. I'm sorry. Okay. I will monitor my email a bit, so in case we have more people. Yeah, what? I'm going to try and let as many people, sorry. I'm trying to let more people in who have, so please, if you haven't got an email, if you haven't sent me your email, do so, and then I can send you every week the link. So I wanted to explain, so it's only problematic today because Liviu, who should be the host, isn't the host today because he got involved in a car accident. He called me, he's okay, but that's why he's not here to host. So I'm sorry about that. I just want, without further ado, I want to introduce Majie Fan, who's going to talk to us about Eocene East Asian summer monsoon in Bohai Bay. Thank you very much. I think you have control, so you can start the...
Okay.
That's great, thank you.
A little bit slow here as well. What's wrong with my computer? It moved ahead of me. Doesn't want to go back. Come on. Okay, good. Okay, so first I would like to thank the host committee for organizing this session. So we got the opportunity to learn from each other. So today I will talk about the sedimentary record of Eocene East Asian monsoon in the Bohai Bay Basin. I would like to give the full credit to the first author of the papers we published together, Dr. Yiquan Ma. He is currently a researcher in the Chengdu University of Technology. So a couple of years ago, Yiquan visited me as a visiting PhD student, and he got this incredible opportunity to access some drilling course from the oil company. And we tried to work together to make an interesting project that can build upon both of our expertise. So I'm glad it worked. I'm sorry, it looks like, it sounds like this room probably have some sort of thermostat issue. So every few minutes you will hear a bee. Okay, so let's start from the modern Asian monsoon. This picture was from Alex's paper, basically showing the modern Asian monsoon that includes the winter monsoon that blew southeastward. And then the Asian summer monsoon include two branches. For most people, we agree on that. That is Eastern Asian summer monsoon and the South Asian summer monsoon. Some people will think that there's a transition zone in between the Eastern Asian monsoon and the South Asian monsoon. There's also other thing that there's the Western Northern Pacific monsoon that mirrors the Indonesia Australia monsoon. And on the top of the monsoon system, these green arrows basically represent the westerlies. Okay. So when we talk about monsoon, this figure clearly shows that there are two climate elements. One is the seasonal change of wind direction, such as in Eastern China, where we are going to focus on. During the winter time, we have southeasternward wind. And then during the summertime, the wind is generally from the south or southeast, okay? But wind record or wind direction record in the geological history is really hard to unravel. So essentially, most of the research that we conducted to look into the early monsoon history and also how monsoon evolved, we looked into the seasonal change in precipitation. basically because the winter monsoon is typically dry, and then the rainfall, the mean annual rainfall was mainly coming from the summer monsoon, okay. So Alexis gave a great talk 2 weeks ago and has summarized some of the paradigm shift. Okay, so I remember about 20 years ago when I was a student in China. So I grew up on the Loess Plateau, and so that's how I developed an interest into the local geology and also the paleoclimate. So I didn't know that the Loess was such a famous paleoclimate record until I get into college. But those are the Platos I played when I was a kid, okay? So about 20 years ago, as a student, I learned that Asian monsoon was all just related to the uplift of the Tibet Plateau. But 2 weeks ago, we heard from Alexis summarizing some of the cutting edge research showing that the monsoon was related to the seasonal shift of the intertropical convergence zone. So this figure from Spicer in 2017 shows the distribution of the major monsoon systems around the globe. So they are distributed within 30° north and the south, okay, within the impact area of the ITCZ. We also heard from Alexis that you cannot kill a monsoon by removing the high topography in Asia. If there's a temperature latitude, then there will be a monsoon. He also demonstrated in many paleoclimate simulations that the paleogeography and the paleotopography, particularly the high mountains in Asia, as well as the retreat of the Parthethys and northward movement of India and the closure of the New Tethys, can modify the strength of the monsoon. So look into a history of the monsoon study. So this figure was summarized from Sun and Wang in 2005. So this research was based on a large compilation of lithological data sets as well as paleobotanical data sets in China. So that basically showed that zonal climate characterized the Paleogene, but the monsoonal climate started in Neogene time. So in this figure, the gray zone basically represents the relatively wet climate, okay? And then the white area represents the arid zone. Okay, so we see during the Miocene time, this pattern is more wetter climate in southern and eastern China started, and that persisted through Pliocene. And we see that this pattern pretty much similar to today, that the region in southern and eastern China, they're impacted by the Southern Asian monsoon and the Eastern Asian monsoon. Okay, so zoom into the East Asia area. We know today that's where the East Asian monsoon prevails, okay? So there has been some study conducted to show that the Eastern Asian summer monsoon perhaps started in the Eocene time. And because we still do not understand the climate elements that well, and also we wonder if the Eocene monsoon was really driven by the same mechanism as the modern monsoon. So in the literature, we call it as proto monsoon or monsoon-like, and we're a little bit cautious on that. Okay. So there are several groups of study has been conducted to look into the monsoon record. The first group of data is from the flora-based reconstruction of temperature and precipitation. So this figure we're looking down here is reconstructed precipitation versus temperature. This is from Chen et al. 2012. by looking into the leaf fossils. So we see that the reconstructed winter temperature and precipitation are clustered in this area. And then the summer temperature and the precipitation are clustered in this area. So this clear separation shows that there's seasonal change in climate, okay, particularly precipitation amount. So that suggests there is monsoon climate during the Eocene time. The other group of study is based on sedimentological observations. So this example was from Wang et al. 2013. So this is actually coming from the same area of our study, basically the Bohai Bay Basin in eastern China. So they also looked into the Shahejie Formation. That's where we're gonna present our record. So the Shahejie Formation includes several members, okay? So we see that in this member called part 3, part 2, we clearly see from these lithological symbols that there's some sort of variations of lithology going on, okay? And then look into the details. The white bars with dots basically represent sandstone that was interpreted to be deposited in the delta environment. And then the gray bars are the mudstone that was interpreted to represent deposition under a semi-deep lake environment, okay? So we see the alternation of these two lithology in most part of the part 3 and part 2, okay? Suggests that there's some sort of cyclicity. And if we think that the migration of the delta at the progradation of the delta is related to the lake level change, then this cyclicity in the lithology can be related to lake level change and then climate, a precipitation amount within the lake catchment. Okay. So on the top of the cycles, there are extreme waiting periods. So here we are looking to this black bar and another black bar down here. Those are coal deposit in swamp environment that represent particularly wet climate and the lower lake water in this case. Okay. So then the third type of study is, of course, the paleoclimate simulations. Okay, there has been a lot of such publications. So I just basically present two examples. One, again, is from Alexa's paper that was published in 2014. So here we're looking into the both the wind pattern as well as the daily rainfall in summertime, okay, with the purple and red color represents more rainfall, basically wetter climate, and then yellow represent drier climate, less rainfall, okay. So these dots basically represents our study area in eastern China. So we see that in this model simulation based on the Eocene paleogeography and also Eocene climate, particularly CO2 level, we see that the wind pattern during the winter time was south eastward, and then that changed during the summertime. We start to have the wind coming from south. This is another study by Tardif, just published recently. They also looked into the Middle Eocene time, about 40 million years ago. So for the winter time, well, this figure, let me just back off a little bit. This figure does not show the precipitation amount. It actually showed the sea level pressure anomalies. So with the red as a high pressure system and then the blue as a low pressure system. So we see that during the winter time, and we have a high pressure system in Central Asia, in mass majority of Central Asia. This is clearly different from today that the high pressure is in the Siberia area. Okay, so this divert the westerlies northward and then the easterlies southward. Okay. And then during the summertime, we see the Tibet Plateau start to form a low pressure system around it, and that alters the wind pattern and brings precipitation from the ocean to eastern China and make the climate supposedly to be wetter. Okay, so as I mentioned, our new record is coming from the Bohai Bay Basin, which is basically close to Beijing, to the south of Beijing city. Okay, the Bohai Bay Basin include several sub-basins, and specifically, we're going to be looking into this sub-basin called the Jiyang sub-basin. And zoom into the Jiyang sub-basin, we can see that it contains several depressions. And then in between the depressions, we also see some paleo uplifts, okay? We looked into cores. So we had two core, one's numbered Lord 69, the other is numbered N1. Then we can look into the position of the sedimentary package within the basin by following this cross section from south to north. Okay, so this basic left side is the south of the basin, and the east side is the north of the sub basin. So we see that the sedimentation are basically the Cenozoic sedimentation are basically bounded by these major normal faults, okay? Same as here for this depression to the north, okay? And the Eocene sedimentary rocks here labeled as ES4, ES2+3, and also ES1, okay? We see that they all more or less show a pattern thickens toward the basin bounding normal fault, okay? So basically this shows that the basin was a rift basin, and the Eocene rocks that we're gonna be looking in were deposited during the active rifting stage of the basin, okay? Here I'm showing is a simplified stratigraphic column for the Bohai Bay Basin. And we're gonna be looking into the Eocene and the early Oligocene Shahejie formation, basically this part of the stratigraphic column. You can tell from the lithology legends that the deposit here are characterized by oil shale and a little bit of calcareous, some calcareous mudstone. So they're basically dominated by these two lithology. There's a little bit of evaporite at the very bottom of the unstudied interval. So overall, we're going to be looking into the upper part of the fourth member and the lower part of the third member. So this interval roughly have an age of 45 to about 40 million years. So the age constraint is not perfect. So this essentially is based on lithologic correlation with the other sections within the Bohai Bay Basin. So in the other sections, there are two volcanic ash absolute age has been provided in literature. There's also magnetostratigraphy study on the outcrop. People has done astronomical tuning to refine the age, but those studies were not conducted from our cores or the depressions that our cores were drilled from. So essentially, this was based on lithological correlation to other areas. But more or less, okay, this section we agree this is the Eocene time. Okay, the section we're going to be looking into is the Eocene time. Okay, then let's see. We have the simplified stratigraphic column again for these two cores now. Okay. So we can tell from the legend that we basically have four lithophases, okay? And these lithophases were based on observations of sedimentary structures and also the dominate minerals based on XRD analysis. I'm not going into the details of that. So you can tell that for most part of the core, the lithology is this gray, which basically we classify as laminated calcareous mudstone. And then the second dominate is the red, which we call the massive calcareous mudstone. And then we have a little bit of yellow, which is the silt-bearing clay-rich mudstone. And then we have a little bit of blue at the very bottom of the studied interval. That is the contains a lot of evaporite and also interbated with mudstone. Now we can look into the details of the lithology. So the laminated calcareous mudstone is the most dominant lithofacies in both of the cores. This is how it looks like in the core. I can clearly see that's well laminated, okay? And then we can zoom into one of the area and look at it under the microscope. So what we see here is this dark and light brown intervals alternating with each other. So within the darker interval, they are enriched with cryptocrystalline calcite, okay? There's also a little bit dolomite in it. Cryptocrystalline basically means the grain size of the calcite of the carbonate is so small that you have to use a very high magnification microscope to see that, which is typically in terms of carbonate diagenesis, this is good target to study because this type of carbonate typically is not influenced by diagenesis. And then the lighter interval is actually clay and the silt rich. So we see some small grains, those are actually silt, coarse silt. So the interpretation here is that giving carbonate are mostly produced by algae bloom, and algae production is high during the summertime. So this dark interval with carbonate should be formed during the summertime, and then perhaps the clay and the silt-rich interval was formed during the wintertime. But the other way also works, okay, because the Eocene climate is warm. Okay, it's warmer than today, so the winter should be not as cold as today. So it could, the interpretation could go the other way as the calcite product formed during the winter time. Okay, but the clay and the silt-rich interval or lamina formed during the summertime when we have a lot of rainfall and wash a lot of the clastic grains from the lake catchment into the lake. Okay. We also see some fishbone under thin section. This slightly distort the lamina a little bit. Okay. We also observe glauconite. Okay. This is also documented in modern lacustrine environment and shows that the presence of glauconite typically is at deeper water depths, more than 35 meters. So taking all this together, we think that the laminated calcareous mudstone was deposited in the deep lake. So where the water energy is low, the deposition environment is pretty quiet. So this fishbone even did not interrupt the lamina. And then the second lithofacies is the massive calcareous mudstone, which mostly distributed in the lower part of the third member of the Shahajia formation. So we see it massive, basically we don't see any sedimentary structures in the core. And then we cut the thin section, look at under the microscope, we see that, yeah, it has a lot of crystalline carbonate. And also there are small ostrobot, we think this is ostracot fragments, okay? So the presence of these fragments suggests that there's some sort of agitation within the water to break the ostracods into pieces. And also we have a lot of, which I will not show here, we have some data of the chemical weathering index to compare between these massive mudstone faces with the laminated mudstone faces. That basically shows the climate seems drier during this, the deposition of the massive mudstone. So taking that together, we think that the massive massive mudstone was deposited in the shallow lake, basically shallower compared to the laminated mudstone. And then the third lithophase is this silt bearing clay-rich mudstone. So you can see that there are some white intervals within the core, and some of these even have erosional bases. We also see there are laminations in this with some angles. These are cross laminations. And in other area, we also see these ripples, okay? In the other part of the this lithophases, we see there are a lot of perturbation, okay? Essentially the, my mouse is not moving. Okay, now it's moving. So we see a lot of perturbation. So overall, this lithophases was interpreted to be deposited in the pro-delta environment, and with this silt mostly delivered by the very frontal part of the delta. Then the last lithophases is called Intubated evaporite and mudstone. So we see that in the core, they appears as intubated light gray and dark gray. We cut thin sections, we look at under the thin section, we found that in this white interval, it has abundant android grains, which is basically a evaporite. This is how the android grains looks like in one of the interval under plain light and crossed polarizing light. And then in between the android intervals, we also have clay-rich intervals that is shown here as a black, nearly black color. So these mudstone in between the evaporite layers, sometimes are massive, sometimes are laminated. But to have a lot of evaporite, we know the lake water must be salty, so this was deposited in the salt lake. So then we can look into this lithological change again, lithology change again within the two cores. So we see that in the lower part of the two cores, okay, there's some alternation between the two dominant lithophases, the laminated calcareous mudstone and also the massive calcareous mudstone. So as we interpreted from the lithophases analysis, the laminated mudstone was deposited in the deep lake. The massive mudstone was in the shallow lake. The pro-delta should be shallow. The salt lake should be the shallowest among all. So this alternation between the two lithophases suggests to us that the lake level had frequent variations during the Middle Eocene time. This was most likely governed by precipitation amount. Okay, so in addition to the lithological evidence of the cycles of climate change, we're also going to look into the stable isotope record. I'm just going to spend a little bit of time to talk about the basics of stable isotopes. So basically, oxygen has 3 isotopes, okay, and oxygen 18 is the most dominant one, which has a slightly smaller mass compared to the other one we're going to be looking into, which is the oxygen 18. This mass difference between oxygen 16 and oxygen 18 leads to isotope fractionation between two phases, for example, precipitation and a cloud or vapor, and also between water and carbonate minerals. Because the oxygen 18 amount is so small, we basically created the delta notation, which is widely used in stable isotope geochemistry to show the O18, O16 ratio of a sample relative to a universal standard, okay? And then this ratio of the two, of the sample and the standard minus 1 times 1,000, the unit is in per mil. So stable isotopes, particularly oxygen isotope in water, can be used to understand the monsoon, basically because several studies or many studies in modern precipitation has showed that the delta 018 value decrease as precipitation amount increase. So this is a figure of a group of data from Africa, showing that we see that as precipitation amount increase, the delta 018 value decrease. Okay, so this is called the amount effect. But seasonal delta 018 value change in precipitation is not only driven by amount effect, it's also related to change in moisture source and temperature. Therefore, this complexity give to caution that when we interpret the data, we need to look into many factors. So we are interested in using stable isotopes to look into the ancient record of monsoon. Okay, back then, in the ancient record, the water has been long gone. So what we're gonna do is use the delta 018 value of the carbonated minerals to reconstruct ancient water delta 018 value, and from there on, look into the climate element. There are several complexities of this process. One is the isotope fractionation of oxygen isotope is temperature dependent. So we have to estimate the temperature or independently constrain the temperature in order to interpret the delta 018 value of ancient water from the delta 018 value of the carbonate. It also turns out that the type of carbonate minerals, for example, dolomite versus calcite, aragonite, also they have different fractionation factors, therefore different reconstructed surface water isotope values. We need to be very cautious about diagenesis, because if diagenesis happens to carbonate mineral, then that original information we want to look into will be wiped out. We also need to assess the influence of the evaporation, because when we look into the change of the isotope value, evaporation can easily increase the delta 018 value, and we want to rule out the influence of the evaporation on our oxygen isotope record. Okay. So stable isotope record has been great in tracking or in presenting the elements of modern monsoon. So this group of data on the left is from New Delhi. So we are looking at the temperature change here and also the precipitation amount change, which is basically from January to December, but during the summer, only during the summertime when the precipitation amount increase and also temperature increase. And then during this time period, we see the delta 018 value of rainfall represented by this square drops. Okay, this drops during the summertime. So this has been mainly a result of the amount effect. So this is quite characteristic to the South Asia summer monsoon. And then look into the study area in East Asia, where we're going to examine the East Asian summer monsoon. We also look into the modern precipitation isotope values. So we're looking at the data from two cities adjacent to the Bohai Bay Basin. One's from Tianjin, and the other is from Shijiazhuang. So we see that the blue square basically represent the precipitation amount for each season. And then on the top of that, the black dots represents the precipitation delta 018 values. So immediately you can tell that the spring, summer, and autumn precipitation has positive isotope values compared to the winter precipitation in this area. This is because of the seasonal change in moisture source and also temperature. But then look into the warm seasons. Okay, summertime precipitation amount increase. Okay, in both cities, and we see the delta 018 value decrease. So we think this is the amount effect of the monsoon. So the stable isotope record has been used to reconstruct monsoon in Neogen time, and also Alexis has pushed this record back to the Eocene in Myanmar. So in his study, he looked into the tooth enamel and also freshwater gastropods. So in these two plots, we're looking at is the variation of delta O18 value from about 40 million years ago to recent. So this plot is for the tooth enamel. This is for the freshwater bivalve. So we see the widespread of data for each time interval, okay, from both the tooth enamel and the gastropods. So this shows large variation that tells us that there's seasonal change in the delta O18 values. That has been attributed mostly to the precipitation delta O18 value change. Okay. To me, the most powerful data to show there are monsoonal climate is the seasonal variation from these gastropods. Okay, so here we are looking at the delta O18 value along the growth bands of several gastropods. So within each gastropod, we see that the delta O18 value has these cycles with a magnitude of 3 to 4 per mil of variation. One of these cycles from the peak down to the valley, then up to the peak, this should be a record of 1 year. So it clearly shows that there's seasonal change of the isotope precipitation that is very similar to modern precipitation isotope values. Another similar study has been conducted in the Sedimentary group in the Himalaya foreland, again, showing that this is actually to the freshwater bivalve, which is basically my favorite type of target to study the cyclicity of isotope value variations. So here we also see that the delta O18 value has pretty large seasonal cycles. In some cases, this is up to even 10 per mil. These type of animal can track the seasonal change in precipitation basically because they grow a bit every day. In some cases, the daily growth band can be even seen from a cross section of the unionate. Okay, so we're going to apply stable isotopes into the cores from the Bohai Bay Basin. As I mentioned, we really need to be careful about diagenesis because diagenesis can wipe out the original signal. So we looked into many sections and we ruled out the interval that has sparry calcite vents, looks like this. Okay, so we only focus on collecting our data from the intervals that has cryptocrystalline carbonate, which are primary lacustrine precipitates. We also conducted XRD analysis to show what are the carbonate minerals. So we show dominant carbonate mineral is calcite, but in some interval, dolomite does present. Okay. So look into our stable isotope record. We divided the samples into 3 groups. The blue here is the sparry calcite, and those on this delta O18 and the delta C13 cross plot, this group of data, the sparry calcite isotope value clearly stand out, okay, and it's lower compared to the other sets of data. So this is the sparry calcite is a result of diagenesis. So it shows its distinctive isotope values from this originally precipitated carbonate. And then the red is, we call the category 2 carbonate. This has more dolomite than calcite. So basically dolomite content is more than 10. So with that, this group of data show a large or broad variations of the isotope values. And the other category, we call category 1 here, has dolomite content less than 10%. We see this group of data shows up to 3 per mil of a variation for the delta O18 value. So these two groups, category 1 and category 2, they are original carbonate, and their delta O18 value should reflect the delta O18 value of the lake water and also the carbonate formation temperatures. Okay. Further, when we look into this correlation between the delta O18 value of the dolomite and also dolomite content, we see there's a clear positive relationship with higher dolomite content showing a higher delta O18 value. So we suggest from this plot that dolomite was formed under evaporation. So when the lake water experienced the evaporation, the isotope value, delta O18 value are increased. So we're gonna mostly look into this category 1 carbonate that has less than 10% of dolomite. And we think this group of carbonate was minimally influenced by evaporation of the lake water. So that can potentially give us the climate signal of the monsoon. Okay, so now we can look into the our delta O18 record, okay? So we stack these two cores together. There's an interval that overlap with each other. So we can see from this variation of the delta O18 values, there's up to about 3 per mil of variations. Okay, so if we attribute this 3 per mil of variation completely to temperature change, that suggests there need to be a 12 degree of temperature fluctuation. Okay, this seems very unlikely given that the yearly temperature variation today in Beijing is roughly only 2 or 3 degrees Celsius. So temperature likely played a role in the variation of the delta O18 value, but it shouldn't be the dominant cause of the variation of the carbonate delta O18 value. So the other end member is if we maintain the temperature stable, the water delta O18 value can fluctuate up to 3 per mil, okay? But as I mentioned, because temperature variation should be small, and most of these variation were attributed to the change of the delta O18 value of the lake water. Okay. Then if we look into modern precipitation, again, this is in Tianjin and the Shijiazhuang, we show a nice correlation between the summer precipitation amount versus the annual delta O18 values. So when summer precipitation amount increase, we see that the delta O18 value decreases. Therefore, if we learn from this, from the modern relationship and apply that into the Eocene, we think that the delta O18 value are mostly related to the summer precipitation amount, with the lower value represents more summer precipitation amount, and the higher values represent less summer precipitation. So we see this variation. Each of our sample roughly represents, because we really didn't look into the high resolution data. So each sample roughly represents a few thousand years or up to tens of thousands years, okay? So we look into the Pleistocene and Holocene climate record, okay, and see how people interpret this type of variability. This is from the stalagmite record in the Hulu cave, which shows the carbonate delta O18 value variations. So we see there's 2 types of cycles, okay? These yellow bars basically represents the higher value in each cycle. And then we have the valley with the lower isotope value in between, okay? So this type of cycles has been suggested to be related to North Hemisphere temperature. So this column we are looking at is the Greenland ice temperature, which is a good record Greenland ice delta O18 value, which is a good record of North Hemisphere temperature. So this correlation suggests that the monsoon intensity in the Pleistocene and Holocene time seems to be related to North Hemisphere insulation. There's also this variation of the cycles of longer time period, okay? So essentially there's another cycle of longer time scale. So we see that it seems from our low resolution data, there are also similar cycles present in our record, potentially suggests there's even longer cycles of this climate variability in the Middle Eocene time. And then we also look into the magnesium calcium ratio, which is a good record of salinity and also dolomite content. We see in 2 intervals, there are significant variations of magnesium and calcium ratio, as well as dolomite content, okay? Those are associated with high delta O18 values. So clearly this peaks, these high delta O18 values associated with high magnesium content and dolomite represents evaporation happening in dry climate. And we also have overall two intervals that show a lot of this variation seems drier compared to the other intervals. So again, I'm going to look into the Holocene climate record to interpret what does those variation mean. This is a record from the Lonar Lake in central India. So there's a bunch of data here, but we can ignore most of that and focus on the lithology. So there's two intervals show that there are evaporite in it. And also during this two interval, the organic compound delta C13 value, which is a good record of proxy, pretty high. These values are pretty high, suggests there are evaporations. This lasted for about a little bit over 1,000 years. And this was called the prolonged monsoon drought in the Holocene. So I would think that each of this drying period, each of the data point in our record can be analog to these Holocene dry events in monsoon climate. So what caused those particularly dry climate events in the Eocene time? If we look into modern climate simulations, it's been suggested that the drought was related to the Indo-Pacific warm pool, which is basically elevated sea surface temperature area in this region. So their climate simulation shows that with the impact of enhanced warm pool and also the synergies with solar insolation and the enhanced warm pool, in our study area in Eastern China, the monsoon precipitation is reduced, it becomes drier, okay? So that explains the Holocene drying events. But we are not sure if the Indo-Pacific warm pool even existed in Eocene time, given the paleogeography was significantly different compared to today. So I will leave this as a discussion point if people has something to contribute. So this leads to my conclusion slide. So basically, we show that from the lithological evidence and the oxygen isotope evidence, that there seem to have seasonal climate variability, particularly related to precipitation, summer precipitation amount change in the Bohai Bay Basin. But as some of you may point out, may be thinking that your resolution of the climate record is pretty low. So far, you haven't demonstrated on the annual resolution whether there's the seasonal change in the precipitation amount or not. And I totally agree with that. So there need to have more studies in the intervals. And Yiquan is very interested in conducting more study to those valves to particularly tease apart the influence of seasonal temperature variation and precipitation delta O18 values. So he's looking into carbonate isotope values and temperature proxy. And we are also really open to any collaborations that can build upon the current understanding to bring more understanding about the Eocene monsoon from this course. Okay, thank you very much. And I'm sorry I ran it a little bit late, and I hope it's okay. And please let me know if there's any questions or anything to discuss.
Thank you very much. Thank you. So if you do have questions, maybe you could put them in the chat, and either I'll call on you, or you can just, or I'll ask the question for you. So actually, I have a quick question.
Mm-hmm.
So the sediment records you're looking at, do you know where is this sediment coming from? Presumably, is it a constant drainage area? Are you worried maybe about how changes in the drainage pattern might affect your proxy record?
That's a very good point, Peter. We really haven't looked into that. But based on tectonic setting of forming rift basin, so that most of the sediment should just coming from the local area, the paleo high that it was bounding the rift. But really, we haven't looked into the provenance record to see if there's any change of the sediment source or not. There's also, I'm interested in is if, there's the Eocene loss record, could some of this core silt we are looking into, the cores are actually the wind transported loss. So yeah, but I don't know how to look into that yet because it's difficult to just extract those grains, and then they're very teeny.
Right. I had another question actually. You talked about short-term variations, but I wondered, what do you mean by short-term? What was the age control like? I mean, there could have been. I mean, I guess it depends what you mean by short.
Yeah, a very good question, Peter. So the time scale it's not great. Okay, we don't have a great time scale yet. So the resolution of the sampling is also pretty low at this point. So when I say short term, I just basically really saying that this data is higher, this data is lower. Okay, so each of the sample potentially integrated several, if it's for the laminated interval, if truly those are annual valves, we may integrate a couple of years, okay, for each sample, because traditional analysis just requires a bit of more material that you can just simply drill from an annual valve. And so also for those massive interval, if the deposition rate is slow, probably talking about a few thousands of years or tens of thousands years. So that's what I mean short. And then when I say longer, probably I'm talking about these cycles that is a few hundreds of thousand years.
Okay, so actually this relates to one of the other questions here. Someone is asking, do you have a precise chronological limitation?
Well, we know we're looking into Eocene, okay, roughly 45 to 40 MA, okay. But the absolute dating of those cores are difficult, and each one is working on astronomical tuning. But that to me just basically increase the resolution of the age control. But yeah, absolute dating of the core, again, it's difficult, and we don't have that data.
Okay.
It's based on the correlation with the other areas within the Bohai Bay Basin.
So let me see, Robert ST, would you like to ask your question?
Sure. Hi, Majie. It's Bob.
Hi.
Stern. Do they know how much lust is deposited in the Bohai Sea now?
Oh, that's a good question. I haven't looked into
Why don't they just measure it?
Information. I don't know if anyone in the audience knows about that.
I mean, why don't they just put out some kind of a trap and measure it?
Oh, you mean modern? Well, in modern, their dust even made it to the middle of the Pacific Ocean. They even argue that the dust from Asia reached Western USA. Yeah, so they looked into, well, they're also looking into the Miocene record in the Pacific Ocean.
No, I mean, just right now. I mean, this winter, how much is, right? The lust gets deposited in the winter?
Yeah, I think, yeah, they can look into that.
So just put a trap out and measure it for a few years.
That's a good point.
Okay, they don't know.
Yeah.
Oh, okay. Thanks.
Yep.
So Tom Reno, do you want to ask your question?
Yeah, just curious for the, so winter snow contribution to the lake water.
Can you repeat that question again?
How much winter snow contributed to the lake water?
Good question. We really cannot tease apart snow versus rain from the isotope record. We cannot do that. Yeah. So
yeah, just curious.
Yeah, but generally, if you think that in the Eocene is warmer than today, there should be less snow compared to today.
So no winter monsoon.
We don't know. I mean, yeah, we don't know.
Yeah. It must be. It must have been very dry anyway.
If we look into the winter monsoon here, the only proxy I'm thinking is maybe we need to look into the morphology of those coarse grains to see if they are transported by aeolian process. But there may be other ways we can look into that for this record.
Yeah, good idea. Thanks.
We have a question from Raj Podder. Raj, can you ask your question?
Hi.
Go
Actually,
ahead.
I am interested. I am interested that you described that the effect of East Indo-Pacific wormhole in your study area from the modern respect to Eocene. So, how you differentiate these two time period?
I really don't know if the Indo-Pacific wormhole even existed in Eocene time. I mean, to me, I always, when I interpret the record, I like to use modern understanding as an analog, but modern understanding not necessarily applicable into the Eocene. We know that the land sea distribution are different. The global mean annual temperature was different. So that's why I put a question mark here. Say probably there's not, probably there's yes, but if it's not, what else could cause those drying events?
So, do you think that at that time the summer precipitation have the major effect on this area?
Can you say that again? I'm sorry, I didn't catch it.
So, do you think that the effect of summer precipitation or East Asian monsoon precipitation is much more at that time?
It's more the summer precipitation is much more what?
At that time, Eocene period.
It's more intense compared to today or less?
It is. Yes.
Well, seems less if we just look into completely the magnitude of variation. This magnitude of variation is up to 3 per mil in the Eocene, but some of these variations should be attributed to seasonal temperature change that will make the amplitude smaller. Compared to today, this amplitude we are looking at just from the precipitation, it's about 3 per mil. Therefore, if we just simply judge from the magnitude of the isotope variation and use that as a proxy, so the intensity should be generally smaller compared to today.
Thank you.
Okay. Anil Gupta has made a comment about using the titanium calcium ratio as a proxy for aridity. I don't know if you want to comment on that. But otherwise, I would say two things. Majie, could you send me references to the papers you were talking about, and then I can distribute those to the people on the email list?
Sounds good. Will do.
And secondly, if you didn't get an email from me, or if your friends didn't get an email, send me your email and I can send you updates. But you can also check on the website if you're in any doubt. So I wanted to emphasize the fact that the Zoom link will be different from week to week. So you can't keep just going back to the same one. I'll send you a fresh link every week, but only if I have your email. Okay? But otherwise, yes, we're sorry about the confusion at the beginning, but if there are no other talks, please join me in thanking Majie for a very interesting talk, and I look forward to seeing you all next week. Thank you.
Thank you, guys. Thank you for the opportunity.
Thank you. It's greatly appreciated. Oh, and remember, you'll be able to look at the recording on YouTube as well, in case you missed something or your friends missed the talk. But thank you very much.
Thank you very much. Bye.